How did we come to understand bone health and osteoporosis? The journey to understanding bone health and osteoporosis has been a fascinating one, unfolding over centuries through careful observation and research. It all began in the 18th century with John Hunter, an English surgeon. He discovered that bones are not just static structures but dynamic ones that continuously remodel. This means old bone is broken down while new bone is formed. Hunter's findings laid the groundwork for understanding osteoporosis, which occurs when bone resorption, or breakdown, outpaces bone formation, resulting in weakened and porous bones. The term osteoporosis, which translates to porous bone, was introduced in the 19th century by French pathologist Jean Lobstein. He observed bones with unusually large holes, helping to define osteoporosis as a specific condition. Later, in 1885, Gustav Palmer made an important distinction between osteoporosis and other bone diseases, such as rickets and osteomalacia. He showed that osteoporosis involves a loss of bone mass, rather than issues with bone mineralization. Fast forward to the 1940s, and we see a significant breakthrough when Fuller Albright identified a crucial link between estrogen deficiency and osteoporosis in postmenopausal women. This discovery shed light on why osteoporosis is more prevalent in older women and highlighted the hormonal influences on bone health. As research progressed, scientists began to explore the cellular and molecular mechanisms that control bone remodeling. Studies of rare genetic bone diseases revealed important pathways, such as the Wnt signaling pathway and the roles of osteoclasts, which are cells that resorb bone, and osteoblasts, which are responsible for bone formation. This understanding has paved the way for targeted treatments for osteoporosis, including medications that inhibit osteoclast activity or promote bone formation. In recent years, genome-wide association studies have identified various genetic factors that influence bone mineral density and fracture risk. However, the complete genetic picture remains complex and not fully understood. Current research also investigates how diet, physical activity, hormones, and genetics interact to affect bone health. In summary, our understanding of bone health and osteoporosis has evolved from viewing bones as static entities to recognizing their dynamic nature and the complex regulation by hormones, genetics, and cellular processes. This knowledge is essential for modern diagnosis, prevention, and treatment strategies for osteoporosis, highlighting the need to maintain a balance between bone formation and resorption to keep our bones strong and healthy.